Hello everyone. Welcome back again. Here we are going to discuss about the case. This is a special case where the unit place numbers adds up to 10. And other numbers remains the same. So in our case we have taken the numbers of 103 and 107. So here 73, that is the unit place number. If you look at here, the unit place number of 7 and 3 will give me 10. These two numbers will give me 10 and other numbers remains the same. That is 1 and 0 here also and 1 and 0 here also. So the steps are quite simple. If you want to multiply 103 and 107, you just multiply 7 into 3. That gives 21 and you multiply the next number with the remaining numbers. That means the remaining number here is 10. In both the cases, you just multiply 10 and the next number, which is 11 o'clock, which gives me 110 and this side is 21. That's all is the answer. It is very simple and very effective in this case. Let's extend it to the next example so that you can understand it better. Let's take the case of 73 and 77. So 7,310. So that means we'll just multiply 7. 3 are 21. And what is the next number of 7? Because this side number is 7. What is the next number of 7? It is 8. So 87 is 56. That's all is the answer. Let's take another case, 9,892. So simple. 8 to the 16. Next number of 9 is 101,090,916. That's all is the answer. Let's take another case. 53 into 5,773 are 21. Next number of 5 is 6, so 5 to 6 are 30. That's all his answer. So this is very simple and very effective technique. Let's extend it further and try to compare that. If I do something in a conventional way, how much time do it take? And if I do in a Vedic way, how much time will take? It will be clearly able to see the advantage of Vedic mathematics. Check out here. We have already given an example of 192 and 198. We are multiplying these two numbers using conventional way. You can see already depicted the conventional way. It is a three-step process involving multiple multiplication and addition technique. Let's check out how it looks like when we use Vedic mathematics 198 and 192. So we are seeing that the unit place number adds up to 10. So I simply multiply them, gives me 16, and this side what I do is 19 is the remaining number. Next number of 19 is 20. I just multiply 19 into 20, which gives me 380, and this side is 16. That's all is the answer. You can see here that after lot of following three steps we have reached at point 38016. You can try out yourself. This will save you a lot of time. This method can save you a lot of time. Let's now expand it to still bigger numbers and see how much time it can save for us. So here for example, we have taken two numbers, that is 10,068 and 10,062. And here you can see that we have to do a 5-step multiplication and multiple addition and then a big addition to find the answer. And if we are not placing the numbers here correctly, then very good chance that we'll mess up this addition and we'll find a different number which is a wrong answer. So let's find out how we'll do in a Vedic way. How much time is it saving 10,068 and 10,062? So here, before applying the formula, we should check if it is satisfied our criteria. 8 and 2 are up to 10, which are the Unit place number and remaining numbers remains the same. That is 1006 and here also 1006. So yes, it fits to our criteria. Let's find out how to do it. 8 to the 16 this side and other side. What we want to do is we want to multiply the remaining number with the next number. Remaining number is 1006. We have to multiply with 1007. That's the next number. To multiply this side of the number, we can apply our old formula what we have discussed previously 1006 and 1007. So base is 1000 here. So this is 6 more than 1000. This number is 7 more than 1000, so 7642. Since the base is 1000, so we need to have 3 numbers on this side. So we'll place a 0 here. And the other side is either 1007 plus 7, 1006 plus 7 or 1007 plus 6, which gives me 13,101. So my multiplication result of 1006 and 1007 is this. So now let's put that number here and we'll get our answer, that is 101,304,216. That's all is our answer. You can check your answer 101,304,216. So that's all this answer. So you can see that here how much time we are saving and actually how less calculation we have to do, just few additions and few calculations, that's it, and we are with our answer. So this is the power of Vedic mathematics. Hello everyone. Last time we have discussed about one of the special cases. So this is the next special case. So next special case is using this. We can find out the square of a number ending with 5 or square root of a number ending with 25. So we'll just check that out. First thing is that square of a number ending with 5. It is quite simple from the last example. Also we can just see that when we do a multiplication. Let's say I want to find square of a number 35. That means it is actually multiplication of 35 into 35s. Previous sections was telling that when we have 5 the number on the unit place also to 10. That is the case here, 5 plus 510 and other numbers remains the same, of course, because we are trying to find the square of the number. So the techniques remains the same. You write 55, there are 25 here, and you take the next number of 3, which is 4, and put here 4 3s are 12, so that's all. SO1225 is the square of 35. So expanding it to any number, you can expand 95, you can write in the same line 25. Next number of 9 is 1090. That's all is the square of 95 is. Similarly, let's talk about 105. Square of 105 is first write 25. Then 10 next number is 11, which makes it 110. That's all this answer. So that is how it goes. It's like quite simple things now. Finding square of a number ending with 5, that's all. So let's expand it to the bigger numbers and we will see how we can do it. Bigger numbers might be little difficult. We may not just write the answer because we have to do some multiplication there. Let's say I want to say some bigger, 125 square. So 125 square means actually 125 into 125. So which is like I can put 25 here, but I need to multiply 12. And 13 12 into 13. So how much ever time it takes to multiply 12 into 13. That much time it will take. So I have like 12 into 13 multiplication. Applying your previous technique, this is 2 more than 10. This is 3 more than 1032. The 612 plus 3 is equal to 15, so 1556. So the answer is 15,625. That's it. So now you can easily find out that how effective this method is compared to a conventional way. So now we are going to discuss about the next case that we told. That is finding out square root of a number ending with 25s. Finding square root of a number in a conventional way is really difficult, tedious and involves lot of hit and try. But here it will be quite simple. Anyway, what we are going to discuss is for the specific case. That number ending with 25. So this is quite simple. You just have to apply the reverse method. Okay, let's say first start with a square so that we can understand it properly. 35 square. We say that it is 25. Into 3 4 that 12, so 12 25. So let's say for us, we do not have the number 35 square, okay. We just have the number 1225 and we want to find the square root of this number. So here you should just little think about it. As soon as you get a 25 on this side, put 5 here. Next these two numbers you try to find out that can I multiply any two consecutive numbers to find this suddenly yes, it is 3 into 4 that is 12. So as soon as you can make out this thing that it is 3 into 4. Then put 3 here, that's all is your square root. Okay, let's take one more thing as we have taken let's 25 square. Root of this number as soon as you should 25 put here 5 next. Number is 20. So what you should do with this number 20? Let's find out. Any consecutive number gives me 20. Multiplication of any consecutive number 4 into 5, yes, 4. Into 5s take the smaller one out of that 4 into 5 is 20 takes the smaller 14. So answer is 45. Let's take one more case. Give me something bigger case. Big, 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 big number. Okay, let's see 11,025 big number. So as soon as you do 25, put 5 here 110 is 10 into 11, right? Take the smaller number, so 105 that's all. So this is how you can apply all these techniques. And while it goes to a bigger number, you really need to think a little more or may we need to do a little bit of application of multiplication results. What I mean by multiplication results is simple. What I mean by multiplication result is when we multiply any conjugated numbers we can start with 1 into 2 gives me 2. 2 into 3 gives me 6/3 into 4 gives me 12 quarters into 5 gives me 20. I will tell you why I am doing this. 5 into 6 gives me 36 into 7 gives me 42, 7 into 8 gives me 56, 8 into 9 gives me 90 and 9 into 10 gives me 8 into 9 gives me 72 and 9 into 10 gives me 90. So from here what I find is whenever I multiply any two consecutive numbers, either the result comes 2, 6 or 0. You can see all the unit place numbers 26, 200, 2620. That means whenever there is a whole square of a number. We are actually trying to find out the remaining numbers should have this number. What I mean is let's when we took 1225, it can very well happen that this number is not a whole square of any number ending with 5. How we'll know that immediately? This is I'm putting 5, but this number, it's a multiplication of two consecutive numbers. I know that by this example. I know that if I multiply two consecutive numbers, either the number here, the unit place number here, that means when I talk about the unit place, I'm talking about this remaining number's unit place. Either it will have 2 or 6 or 0, no other number at all. You can see here after 25. Here we have unit remaining numbers. Unit place is 2, remaining numbers unit place is 0. Remaining numbers unit place is 0. Again, that means whenever you know that it is it is a complete square of 5, any number ending with 5. That means the remaining number other than 5 should contain either 2 or 6 or 0 at that unit place. So that's again a clue. You can really find out that is a number, a whole square or not. That's a clue. If I tell some number of 11,625, so you know that okay, 25 here. Remaining number is 116 and unit place is 6. Okay. It may be a whole square. We are not sure. It may be a whole square. There is a chance. But if I give you some number of 1,025,925 and I will tell that okay. Tell me, is it a whole square of a number or not? You know that ending at 25 means it will be 5 here. But 10,259 is a remaining number and the unit place is 9. But never you can get any number what you multiply with consecutive number and get 9 at the end for sure. Because we have just seen here that we cannot get ever 9 in the last unit place multiplying conjugative number. Only 2, 6 or 0 can come. So here I'm very sure that this is not whole square of any number. It cannot be so by this technique. What you are coming to know is that if it is a whole square, find the square root, and even if you can answer if it is a whole square or not. So those are the two things we are getting out of it. So when you look at mathematics, you believe me, you always look from a point of view that what all I can get out of it. See here we just discussed one technique, but from that we found out some 2 to 3 techniques that we can really use in a lot of other ways. So that's what I mean when you do mathematics, just little bit. Get inclined to it, try to find out more, try to dig out more. It will be interesting. Just do not go by conventional way. Just do not go by, oh, I need to finish this, that's all. No, just go little more, little ahead, digging the numbers. Find out if I multiply all the numbers, what kind of pattern do it give? Can I get something out of the pattern? See here we actually got something out of the pattern. Right? So just think in those terms. You will see lot of applications of this kind of thinking technique in lot of sessions which is coming ahead. Thank you. Hello everyone. Welcome to this tutorial. Today we are going to see the multiplication of the numbers without taking base as 100. That means we want to take some other base so that we can multiply numbers which are not even near to 100, 1000 or 10,000. So let's start with an example. So first example I will take, let's say 76 into 78. In this case, what we do is we see that if we are considering 100 as our base, then it is quite far. So the numbers will come bigger here. The difference from the numbers will come bigger here. But if I consider that those numbers are 80, that means my base is 80. Here if I consider my base as 80, then numbers become smaller. That is 76 is 4 less than 80 and 78 is 2 less than 80. So now in this case my base is 80, which is nothing but 10 into 8. Why do I take this here? The major point is to see this 1010 is our reference base. Reference base is only to make sure that how many numbers we will keep on the right side of our multiplication. So here if I multiply 4 into 2 8, and since I have taken my reference base as 10, so I can keep a single digit here. If I take my reference base as 100, of course that time this value also have to change. But let's say if I take my reference base as 100, so this side I have to keep 08. So I think this you will be able to know if you have attended my previous lectures. So to attend the previous lecture before taking this one. So now my base here is 10. So I have to keep one number here. So I have kept one number here. And what I do on the other side, the same thing, 76, 2 or 78. For whatever I do I get the result as 74. So now what I need to do is whatever is the multiplier from my reference base into the multiplier, whatever I get my working days. So this multiplier has to be multiplied here. So basically I need to do this multiplication. So 8 keeping here from the top, I just keep 8 here. Then this 74,884 is the 32, so 2 and 3 carried. 7 to 8 is the 56 plus 359. So my answer is 5,928. If I take a calculator to check this out, say 76 into 78, so 5,928. That is all is our answer. So this is like taking a different base other than 100. Let us or extend this to still the higher numbers. So this time I will take two numbers which are 3-digited numbers, so 482 into or multiplied by 494. So here if I take my base as 100, so this side I will get the difference as a bigger numbers. But if I take my base as 500, then I will get smaller numbers. So 500s is equal to, I can write is at 100 into 5s. In this case my working base is 500, so the difference will be taken from 500. But the reference base is 100, which means I can keep 2 digits on my right-hand multiplication. So here if I say 482, so this is 18 less than 500 and 494, which is 6 less than 500. So if I multiply this to 186,108. And on this side, either I do 482, 6 or 494, 18. Whatever I do, I get here on this side is 476. Now what I have to do is I have to multiply this guy with 5. So let us multiply this with 5, keep 108 on this side. Multiply this with 5. So if I multiply this with 557, says 30 is 03 carried 5, 7. 35,338 8. Again 3 carried 5,354 s are 2,323. So this is 238. So here as initially we have told 100 has 20 s, so we can keep only two numbers on this side. So this number has to come here and get added. So the final answer will come as 238,108. So let's check this out in a calculator. My numbers where just keep the calculator aside so that I can see the numbers 482 and 4/8 2 into 494, so 238,108. That is our answer. So this works for all the cases. Now the base is 500. You can try with any other number applying the same principle, and I want to do the same process again. If you are thinking that why don't take the base as 1000? We can do the same thing actually till here the process. will remain the same. I'll redo it so that we are clear on it. So 482 into 494, I'll just proceed fast because we have already done this, is 18 less than 500. This is 6 less than 500. So 18 6 are 108, and if I do 482, 6 or 494, 18 whatever I do I get is 476, right? So this time I want to take my reference base as 1000. So I have to write something like this: 500 is equal to 1000 into 2. So my reference base is only to make sure that how much number I can keep on my right side. So here since the reference base is 1000, I can keep 3 numbers, so I can keep all these 108 on this side, need not to do anything. But here if you see, sorry, this is not into, this is divided by. So last time since it was into 5 I multiplied 5 here, since it is divided by 2 here, this time what I need to do, I need to divide this by 2. So if you just do a simple division, they're divided by 2. This comes to 2s are 4, this is 7, so 2 3s are 61 carried. 16,162 8s are 16. So my answer is 238,108. So here also the same answer. So you can do in any way, you can take the reference base as 100 and multiplied by 5, get 500 if your working base or reference base as 1000 halves, and get your base as 500. So that's all is the way. I hope this is helpful. Please do put a comment if you are not clear on this process, and do practice and explain these things to the higher labels so that you have a better understanding as well. Thank you for watching. So now we are going to see the technique to find the square of a number, of course, which is near to some numbers like 1100 or 10,000 kind of numbers. So the rule says like this: lessen the number to the extent of deficiency and put the square of the deficiency, or increase the number to the extent it exits and put the square of it. So taking the first thing, let's find out square of a number, and we will say how it is applicable. So let's take the case of 93. So 93 is 7 less than 100. So to find out the square, the rule says lessen the number to the extent of the deficiency. Deficiency from the base. So base here is 100, so the deficiency is 7. So again less the number by the deficiency. So 93, 7. How much it comes to 86, and then put the square of the deficiency. Deficiency is 7. Put the square of it, that is 49, 7 square 49. That's all is the answer. Let's check out with calculator. 9093 into 938649. That's all is the answer. So let's take one more example to check this out. For the case of, let's say, 89 square. So lessen the number by the extent of deficiency. So it is deficient by 11, then 100. So again we will do a deficient. Again, we will subtract it by 11. So 8911, which gives 78, and deficiency is 1111. Square is 121. We can only accommodate 2 numbers here, so we write 21 here and 1 here. So the answer is 7921. Let's check the answer. 89. Sorry, 89 into 89 7921. So that's all is the answer. So let's check out a bigger number also in this case, that is 989,989 square. So in this case, our base is 1000. So how much is less 989, 1000, that is 11. So lessen it by 11. So that gives me 978. And then put the square of the deficiency 11, put the square that is 1 to 1. In this case, I'll put 1 to 1 because our base is 1000, so we can keep 3 numbers here. So that's all is the answer. 798,978,121. Let's check out 989 into 989,978.21. So you can just imagine that with a single line we are able to write our answer of this. So how effective it is. Let's find out something for a number which is more. Consider the case of 109 square. So here the second part of the rules comes into picture. Increase the number to the extends. Increase the number to the extent it exceeds the base. It exceeds the base which is 100 by 9. So increase it by that base that is 1099 so it becomes 118. And then put the square of it, the increased part which is 9. So 81 is the square. So answer is January 18th 81. Let's check out 109 into 109 so answer is 11,881. That's all. So in this way you can solve any of the questions that comes like this. So you can know that where it applies. So accordingly you can solve it. So let's now find out what is the trick behind it. How does it work? So again it's same simple trick. You'll be amazed to see this. So here what we are doing is we know a square b square ab into ab, thereof we can write a square is equal to a plus b whole into a b plus b square. And the same principle you are applying. Just check out the example you have given 989 square. I can write in the above form as 989 plus 11 and 989, 11 plus 11 square. So here 989 plus 11 gives me the number 1098,911 gives me 978. So I multiply 978 into 1000 which gives main, 97830s and then I put 121 so it becomes 978,121. That's all. It is quite simple actually to understand it is quite simple. While we look at, we feel that okay there should be some very big science behind it, but actually it is not. It is a small things that we miss to observe. Once we observe it, we can really find what's how it can be done. So that's all about it. So finding square of a number near to any bigger number of 10,000, you can apply the same principle and justice write the answers in the single line. So that's all from this lecture. Let's meet on the next lecture to discuss some more tricks. Thank you.